Chapter 7 Homework, Questions 6, 8, and 12. Question 6. Officer salaries. The following table gives the monthly salaries in thousands of the 6 officers of the company. This is the monthly salary of the officer A, officer B, and goes on. Question says, calculate the population mean monthly salary. So to calculate the population mean, these are the numbers of the table, of this table. You basically add them up and divide by the number, the total number, and then you'll find the average, the mean. So we have 8, 12, 16, 20, 24, and 28. You just add them up and divide by 6 because there are 6 different officers, and this is how you get the mean. Also, this table gives 15 possible samples of size 4 from population of 6. So out of this 6, in how many, so this is 15. In 15 ways you choose 4 from the 6. Complete the second and third columns of the table. So this is a completed table. How we get that? Well, we all know the numbers for A, B, C, D, E, and F. We just basically put the numbers in here. If it's A, C, D, E, then we get a number for A, and then C, D, and E. It's going to be 8, 16, 20, 24. And when you look over here, yes, it's 8, 16, 20, 24. We do the same thing for the rest. And to find the mean, actually, of those samples, so there's 4 salaries in here. You just basically add these 4 numbers and divide by 4. You get 14 and 15, 16, and the rest. This is how we complete the table. Complete the dot plot for the sampling distribution of the sample mean for samples of size 4. So we basically will use this table. Look at the population mean. So the population mean we found was 18. So this is how we show 18. And for the plots, what we do is we basically look over here. I'm sorry. So there is, so how many 14s do I see? There I only see 1 14, so I put 1 dot. How many 15s do I see? Only 1 15. How many 16s? 2 16s. How many 17s? 1 and 2. How many 18s? 1, 2, and 3. So we keep going, and this is how we complete the dot plot for the sampling distribution of the sample mean. Obtain the probability that the mean salary of a random sample of 4 officers will be within 1. It means that from the mean, it means 18. So the salary of the officers will be within 1, which means that it's going to be 17 and 19. So when you look at the table or the dot plot, so how many? So out of 15, because the whole thing is 15. In total there is 15 distributions. So there's 15 samples in total, and out of these 15, how many of them is within 1 of 18? So 1, 2, 3, 4, 5, 6, 7. We see 7 samples in here. So because the whole thing was 15, the probability is going to be 7 over 15. Use the answer you obtained in part B and definition to find the mean of the variable. Interpret your answer. So this is what we got in part B from the table, all the means of the samples. And this is the definition to find the population mean. We basically add all the numbers and divide by the population size. So these are the numbers, and we add them up, divide by 15. When you do that, you get 18. Can you obtain a mean of the variable without any calculation? Yes, because we know that the population size equals the population mean equals the sample mean, and we found that at the beginning the population mean is 18, so the sample mean also should be 18. Question 8. So this is an information from a study. So the study examines both full-time men and full-time women in 87 different occupations. So the article says that the mean number of hours actually worked by female marketing and advertising managers is 45 hours. So for females, the mean is 45 hours. and we assume that the standard deviation is 7. Now let's decide if the given statements are true or false. The first one: for a random sample of 196 female marketing and advertising managers, chances are roughly 95.44 that the sample mean number of hours worked will be between 31 hours and 59 hours. This is false. How is it false? It's a sample, so we have a sample size which is 196, and if we work with a sample we get a standard deviation for the sample, and this is the formula. And we know that the sample mean is going to be equal to the population mean, which is 45, and to find the standard deviation of the sample we use this formula. It equals the standard deviation of the population, which is 7, over square root of the sample size over square root of 196. That's going to be 0.5. So for size 196, sample size 196, the sample standard deviation is 0.5. Now let's work with those numbers and let's see if we really get this. If it says 31 and 59, let's first work with 31 and let's get a z-score for 31. So what is the z-score for 31? This is the formula for z-square. You write the number and subtract it from subtract mean from that number and divide by the standard deviation of the sample size of the sample. When we do these, we get -28, so this is the z-score -28. And when we work with 59, we get +28. Well, z-score -28 and z-score 28 actually means it actually talks about the whole distribution. It's the whole thing. If it's the whole thing, it cannot be 95.44. We can say it can be 100. So that's why this is false. 95.44% of all possible observations of the number of hours worked by female marketing and advertising managers lie between 31 hours and 59 hours. Well, this is not possible to tell because we don't know how many observations have been done. We don't know the number. For a random sample of 196, so this is like the question we did in A, so it's the same size, same sample size, but this time it says that 95.44% lies between 44 and 46 hours. Let's check if this is true. We do the same thing, so we find the standard deviation for the sample, which is 0.5, and we find the z-scores for those numbers for 44 and 46. For 44, the z-score is going to be -2. For 46, the z-score is 2. And when we go to the table, the area to the left of 2 is going to be this number, and the area to the left of -2 is this number. And when you subtract the number for -2 from the number for 2, you get the area between these two z-scores. So the z-score between these two, the area between these two z-scores is going to be 0.95.44. It means that, and yeah, this is the area. Because it says the chance means the probability actually. So what's the probability? So area probability is going to be area over the whole thing. So that part over 1, because the whole thing is 1, is going to give you the chance, which is, we get the same decimal, 0.9544, and when you convert it to decimal, you get this number. Question 12. The following graph shows the curve for a normal distributed variable. Superimposed are the curves for the sample and distributions of the sample mean for two different sample sizes. This is the normal curve for the variable, and A and B are for the sample sizes. Explain why all three curves are centered at the same place. Well, of course they're going to be centered at the same place because this is the normal curve for the variable. It's normal distributed variable. So the samples also should have a normal distribution. The sample size doesn't matter, so they should also have the normal distribution. And we all know that the sample mean should be equal to the population mean, so they all have the same mean right over here, and then that's why they will be centered at the same place. Which curve corresponds to the larger sample size? it's definitely sample B. Why? Because we know that the standard deviation for the sample equals standard deviation of the population over square root of the sample size. So when you make n a bigger number, a greater number, you will get a small number for the standard deviation of the sample. If the standard deviation is small, it means that it is less spread. So it doesn't look flat, it looks like sharp, like we see in B. That's why B has a larger sample size. Why is the spread of each curve different? They are different because they probably have different sample sizes. And if we use this formula again, we will, because the sample size for B is greater, sample size for A is less than B, we will get different curves. Which of the two sampling distribution curves corresponds to the corresponds to the sample size that will tend to produce less sampling error? Okay, if you want to get less sampling error, the standard deviation should be small. So if the standard deviation is small, we get a smaller sampling error. And to get the standard deviation small, the sample size should be large. So because in the previous question in here, we found that B has a larger sample size, it has a smaller standard deviation. If it has a smaller standard deviation, then it has a smaller sampling error. Why are the two sampling distribution curves normal curves? Well, this is actually like the first question in here. Why are they normal curves? Well, because the variable under consideration is normal distributed. That's why for any sample we will always have normal curves.